So, hi, Graham. Welcome back.
Thanks very much, Alan. How are you?
Yeah, perfect. So, everything's still exciting. And one of the most important questions for today, is CDI Lite ready to ship?
ready to ship? Probably not. But it has passed the first hurdle, which is to get to cast the vote for approval with the specification process. So it's gone from being an idea, a proposal, to being a real thing. Mm-hmm. So that's good news, because it means it's happening, right? Any doubts of whether it was happening or not have been eliminated. Right?
Very good.
Now,
and what I saw, you became the Jakarta committer, right?
Yes, I am now. I'm now a committer on the CDI project and participating in weekly meetings, planning Lite specification, and yes, I am progressing the implementation on the Micronaut side. So we still have to figure out exactly how to get the TCK running, because it's Lite and build time enhancement is a bit different in terms of how we have to set up the TCK CDI, the existing TCK, which is really designed to be run with like application servers and deploying like JBoss and stuff like that. And which does everything at runtime. So that, large part of the work is going to be reworking the TCK. But in the meantime, I have been working my way through implementing the spec as written in the specification documentation. So I suppose I'm about like 50% of the way through right now. A whole bunch of stuff is working in Micronaut, like produces methods, disposer methods, all the different scopes, contexts are working, so you can define different bean contexts, requirements, programmatic lookup is working, injecting instance, initialization of SE container is working, container initializer. So, a big amount of progress has been made. I think there's still like to do. Next month, I have to start working on the build time extension API, and that's where I think I will get more involved in terms of sending commits and PRs to the project, because the build time extension API is going to have to be evolved over the next 6 months to be in a final version that everyone agrees on. Since this, Lite doesn't include the runtime for extensions, and it essentially has a replacement for build time extensions.
Question. So as a Spring guy, I can tell you, or still Spring guy, or at least you were a passionate Spring guy a few years ago. Are you now proud to become finally a Jakarta committer?
Well, I was really on the periphery of the battle of Spring versus Java guys. Certainly I was a Spring user and Spring developer, and actually, quite a bit of my name is on the Spring data, and sprinkles of it on the Spring code base. But these kinds of religious battles, I think there's definitely things that about CDI specifically that I think are well thought out and nice. There are other things that are like not so well thought out, not so nice. But that's the same in Spring side, right? So that's the same on Spring. So
no, it's not that serious question, but it is always to see the reaction, because I think this is not battle, is more like philosophy. The Jakarta and CDI was all about backward compatibility and like multi runtime, and my point of view is like Spring focus more on best of breed and the best possible implementation. And this is if you're moving fast, you cannot be always compatible, and if Jakarta moves slower, and you have always to have committee to talk between vendors, you are moving slower, and this was maybe the difference. But
that's absolutely the difference. And I think ultimately Spring became dominant. Really, we have to accept reality that Spring is dominant. because developers have real problems to solve now, and if you're waiting around for the latest specification to come around to address those problems, you're not going to solve those problems. So a prime example of that for me was JPA, which JPA took a while, in a specification to manifest itself. Hibernate is clearly an important technology, but while all of that was happening, Spring was implementing support for document databases and Cassandra and Elasticsearch and all the other different types of databases and Redis that have become popular and that are not standardized, right? So or any way, shape, and form, and you can't apply JPA as a specification to those databases, right?
You are absolutely right, but your point of view is more pragmatic. What I saw in project is more like they used Spring with 80% of Java EE technologies like JPA, and there was no explanation for it. So if you would use Spring because it adds added value on the standard, so it's just unquestionable. I mean, you have to use it. You cannot just wait for Java EE or Jakarta to evolve. But I'm completely with you. So if you say you need more than the boring APIs, is what I call the Java EE. It's just I don't care about CDI, it just works. I just pick it. Then it's a different story. But back to CDI Lite. So my understanding of CDI Lite, it will be like the minimum is and means it will come with optional or without even scopes and be better.
It's gonna have scopes, yeah.
But not SessionScoped, I think, no conversation scope. You will only have, I think, the RequestScoped, I think, an ApplicationScoped.
I think ConversationScope is the only one that's going to be. Oh, I think SessionScope is still being debated, but ConversationScope is definitely not going to be included because it doesn't make much sense.
But SessionScope, you only need servlets and HTTP session for that. And it's going to be part of CDI Lite, SessionScope, you think?
I mean, SessionScope, you don't need a Java EE container to support SessionScope, right? Sessions are a universal concept across all HTTP servers. It's not necessarily something tied to a particular container. Micronaut.
Servlets, right? So I would assume.
Yeah. But for example, Micronaut runs on NetT, right? There's no servlet environment there because we support sessions as well. But SessionScope means as well. Yeah, so there's and I think the same for Quarkus, right? Quarkus supports running on Vertex, which is not servlet either.
But you can in Quarkus you can add the usually the HTTP server from Quarkus. I forgot that there's an extension, and then you get proper servlets. I think Helidon does not support servlets at all, I think, right? So Helidon, they say we ignore servlets for now. And
I think they might support the servlets in MP, but I'm not sure the Helidon guys will know more about that. Micronaut supports servlets as well. We have a sub-project that you run Micronaut on Tomcat and Jetty and Undertow and various other servlet environments. And build a WAR file and deploy it to wherever you want.
I tried to find your work on Micronaut and CDI Lite, but it's hard to find. So if you Google for CDI and Micronaut or CDI Lite and Micronaut, there is nothing. So is this like a secret repo where you're working on the CDI, or where to find your work?
Well, most of the work is conversations and discussions right now. So you'll find all of those conversations and discussions on the currently on the CDI mailing list, which they provide weekly summaries of the meetings and discussions. And then there's a GitHub project as well called clipsc4j/CDI, where lots of issues are being created and pull requests are being, and discussion is being happened. Certainly I'll be sending some PRs that way. Many things have been decided there in terms of one of the main ones is splitting of the bean manager interface into two, because Lite cannot essentially support the entire bean manager interface, which includes many things that are not applicable to Lite. The new super interface called Bean Container, which Bean Manager extends from, will essentially provide like a subset of those methods that are compatible with Lite. And the plan is, of course, that you'll be able to go up the stack, right? Where
Yeah.
You can build with Lite and it will work, but you can take that same Lite application and run it in full and it will still work. So, you mentioned not breaking compatibility, and that's still a goal where, the plan is that extensions written for Lite will be able to be deployable to full, and extension, even though they're build time extensions. And applications built with Lite should be easy to port to run on full, essentially.
Mm-hmm. So it's more like refactoring or layering approach, right? So like the layers are now introduced afterwards. So
yeah.
And
When you're running on Lite, you get certain interfaces, and many of these things can be like quarter build time, right? Because Lite is build time oriented. So if you use an API or feature that is not supported in that environment, you would get like build time warnings and errors and so forth.
So now, what is the ultimate goal of Lite besides refactoring? So what I understand is to make it more, cloud ready. So what it means, I can already imagine what's the goal is, but what's your opinion on that?
Well, I mean, fundamentally, if you look at the design of like Micronaut and Quarkus as new frameworks that are, gaining a lot of traction and interest, developers are more and more containerizing their applications and running them in environments like K8s or containerized cloud providers, and these are like essentially like immutable infrastructure, right? Where that don't change. And if you look at the design of like traditional Java E or Jakarta, whatever you want to call it now, containers, they're really designed for redeployment, undeployment, dynamic, changeable state, and that means that they include a lot of features that result in quite significant increases in startup time, memory consumption, and so forth. So, like if you look at Weld, it uses extensive use of runtime bytecode generation, dynamic proxies, reflection, and all of that stuff chews up a lot of memory, which is kind of unnecessary in a containerized world, right? Because it's just not needed. And ends up with applications that increase in startup time, and when you compare building applications in Java, with those kind of existing frameworks, like with existing containers, like sure, of course, you could containerize a big Java application server like JBot and put it in a container, but it doesn't make sense, right? When you want like services that come up and come down and very quickly, and in a microservice environment, and essentially scale up and scale down quickly. Those instances have to start up fast. They have to come and go quickly. They have to be responsive to, and they have to use less memory, right? And this is actually why some companies transition to writing microservice in Go, because they compile some native, and you can put it in a container, and the container is tiny and like scales up and scales down. The comparison I always give is like, Kubernetes itself is written in Go. And imagine if in a world where like Kubernetes was like written in Java, and you wanted to run a local Kubernetes cluster on your laptop, or with like, dozens of containers running dozens of Java versions. We don't even have the amount of hardware necessary to run that kind of, we need to build more optimized container instances, and that's what like Micronaut and Quarkus and so forth are allowing you with, particularly when paired with GraalVM native image, because AOT is also a key aspect of this going native. Is allowing developers to achieve that kind of containerized small application that is, even if it impacts certain aspects. Like, for example, I've been building recently this microservice showcase with Micronaut for Oracle Cloud, and we were using like test containers, right, to spin up instances of backend microservices that one microservice talks to another with. Talks to the other one in an integration test, and you want to spin up the other microservice, right, in the integration test and test it. So that microservice is written, the one you're testing against with test containers, is written in in Java and running in JIT, it actually impacts your productivity, right? Because you have to wait several seconds for this thing to like start up and whatever. Whilst you can spin up a native microservice with Micronaut and GraalVM native image almost instantaneously with test containers. It's typical in the microservice architecture for development teams to provide, here's my service, here's the containers running, and spin it up and test against it. And and if that container takes a long time to start up, it's ends up in a frustrating experience.
But there's an interesting counter movement. I don't know whether you know the guy. This is French. Excuse my French pronunciation, but this is Romain Mani-Boucan. You know the guy from Tommy. And now he's working on a kind of Kubernetes inside a single JVM. And also interesting, GraalVM, of course, they have isolates, right? And in these isolates, they also thinking about now allowing multiple, multiple isolates. It's like a very small, not ears, but how to call it, deployables or not even processes inside GraalVM. So it's also interesting. I mean, that there is a counter movement because Kubernetes itself is very heavy. So, you have to run, all it is very slow. So regardless what you are starting, for me, it is really too slow. It reminds me the old Java E days with Xdoc and everything. When I see Kubernetes is my, impression, not even Java, just starting anything, because until it starts and all the liveness and readiness, all the defaults, and you cannot, put the defaults too low, because if it's too low, then it gets killed. If it's not, it is really hard to make it, how to call it, fast, right?
Absolutely, I agree with you. And like Kubernetes is not something like I don't particularly have any amount of fun running Kubernetes locally on my machine. It's not a great developer. The Kubernetes actually doesn't have a great developer experience, right?
Exactly.
It's it's a bit of a beast, to run locally. But you have to remember that, that it's not, I'm not just referring to Kubernetes. So like Kubernetes is kind of like infrastructure layer, right? If you look at like many, if you look at the cloud and the direction it's going, you have services like Google Cloud Run.
Exactly. This is what will be the next.
And AWS App Runner, and I'm sure upcoming services from Oracle, where basically you can just like say, hey, run this container for me, and scale it from 0 to 100 automatically, and just like manage it, right? And that provides that layer on top is what provides the developer experience, in the cloud. And you have the same requirements there, right? And then of course, apart from that, you have serverless, right?
Exactly.
Serverless, Java is essentially almost irrelevant in the serverless world, because until for many use cases where cold starts are a factor, until native image came along and was like, hey, well, we can build this into a native thing. We can run it like it's completely serverless on Lambda or Oracle function or Cloud Run, and scale to 0, and it comes up and native image. In fact, Micronaut launched the backend for like generating your application, and Micronaut is running serverless, and it has a cold start response time of like just over a second, which is remarkable, right? Largely thanks to AOT, native image, GraalVM. And so, if we had packaged that same application into it and run it via JIT, the cold start would have gone from 1 second to 10, 8 or something like that. So which is unacceptable for a lot of applications that are like trying to like run serverless, right?
Yeah. So what I understood from the CDI, from the thing is this goal of CDI Lite. The main goal is to make CDI more memory efficient and CPU efficient, so it starts faster, and therefore they have to get rid of reflection as much as possible. This is the main goal. If there is no reflection, you can prepare everything at build time, and then everything is smaller and starts faster, right? This is the main goal, which is reasonable.
Absolutely. And also,
Because Lite, if you hear Lite or micro, it's always questionable. So what Lite actually means, because
the name is still not the name is still not final. Maybe it'll be like changed before the end of and we'll call something else. But it's it's relevant for a lot of different use. Like actually, it's going to expand the landscape of CDI applications, right? And take CDI into places where it's just not used today, right?
Yeah.
So I'm talking about places like command line apps, right? Nobody's using CDI to write command line apps because outside of Micronaut and Quarkus, because basically it's hard to convert to native and it doesn't start up fast enough. And then in addition to that, nobody's using CDI to build IoT apps, right? That's another use case where you need to run on device, in a very memory constrained environment. And my colleague Todd Sharp has a great blog series about using Micronaut to essentially run edge nodes on IoT devices and for growing seeds and all sorts of things, right? And creating hot source essentially.
Okay.
So then that's also an important destination. And then thinking a long term, there's interesting projects like Luon where they're actually getting Java running on iOS again, thanks to native image. There's examples of using Micronaut with Gluon, Micronaut for DI to build an iOS application. So we have to look to expand the reach of these specifications, because if CDI stays constrained to just like running on Java EE application servers, then I doubt it's going to see much future growth.
Yeah. Back to the application servers, because I'm a consultant, and my clients ask me what is the right architecture or whatever. And the funny fact is that the application server, so the current one, OpenLiberty, Payara, Whitefly, they are surprisingly well suited to run on the cloud, but in containers managed by, let's say, Kubernetes-like orchestrator, because in enterprise there's actually no need for rapid scalability. Mostly, you have 2 containers running all the time, and if you have to scale, maybe you scale, to 3 or 4 after extensive tests, and they run forever. And the cool story was, because of the separation between the application server core and the WAR, the interesting part is there was no fedjar or uberjar. So what you can do with JBoss and the others is you can create a container image, the base layer, which is the application server with all your libraries, push it to to the Docker registry, and then you would ship several times a day just a tiny WAR, which was perfect. And we just measured the CPU overhead, and this was not that much. So it would never pay off if you would be able to reduce the memory consumption a half or even lower. It simply doesn't matter if you're just running, and sometimes even they buy the hardware in advance from AWS and the others, and Azure, I'm sure from Oracle as well, so you get the discounts. So, but you mentioned something, and this is now becomes the killer use case. The killer use case for Micronaut on GraalVM is serverless, what you said. Because if you, or even, you have to be also careful. What I did a math is to run back Quarkus on JVM mode, a simple application, and it's called, once a second, the entire month. So you will just, pay a few euros. So for that, so this is not a big issue. But of course, if it scales up, if this call takes twice as long, you will pay twice. If it consumes twice as memory, you will also pay twice. So if you have lambdas, which are very popular, let's say, right? So serverless functions, then it makes a difference. Then you get the business case. And if the microservices like, Micronaut, Helidon, or Quarkus can be compiled to native image, you could reduce cost by half or even more. Just, without any changes to the architecture, to changing the framework. And I would say this is the killer use case for the new runtimes, like Micronaut in serverless Lambda, like this is the cloud functions, Azure functions, and Lambdas. And from the architectural point of view, the Lambdas is used often as integration points, not like the main architecture. It listens to Kafka or listens to S3 events and stuff like that. And and the traffic depends on the firehose, basically. So I would say this is because the people say, okay, this is we have to be efficient, and they have huge efforts. They change frameworks, and then they ship a boring application to the cloud which runs on a Docker container in Kubernetes, and there is no scalability in the enterprise. So I mean, this is pointless. But in serverless, it makes absolute sense. And you can go to your manager and show if we change this to GraalVM, we will save this amount of money. So this is very clear because there is a cost calculator on AWS, on Azure, so you can really show this to the business people. But if you try to to show the difference on Kubernetes, this is almost a difference because if your container runs all the time, whether it consumes 60 megs of RAM or whatever, it doesn't really matter, I would say.
Yeah, I mean, the way you build your layers, can certainly, the same happens with Micronaut, Quarkus, Spring Boot, etc. When you build a layered Docker image, you're only essentially pushing the changes to the Docker registry because the way the dependencies are separated out and so forth. But you're absolutely right that for a large amount of companies, it's not going to be necessarily especially migrating existing applications, and that's why companies like Oracle have invested in getting things like WebLogic running on Kubernetes, right? Because you can still, there's a whole bunch of applications out there, those millions of applications out there that still going to run in that environment. So, and that's not going to change anytime soon. But, for these, as you said, for these new workloads, and for new architectures, and for the way applications, should be designed in the future, Quarkus, Micronaut, and so forth, and CDI Lite certainly provide an interesting option.
And what also very interesting, but we already talked about that, is the ability to I know JAX-RS the best. So what we do, we can ship a JAX-RS resource as a AWS Lambda. And this is huge productivity gain because you don't have to fiddle with the not that exciting Amazon low-level APIs with the streams and whatever they offer you. So, the AWS events get automatically transformed to standard Java types, which is huge. So what basically means, what we can do right now, we can pick an existing application and ship it as Lambda. And if it starts fast, this is not like a business decision. What is cheaper? If this is not as popular, we can run as a Lambda, or we can run it as a container app.
Yeah, absolutely. That's the same with Micronaut, right? So with Micronaut Launch, the sample app, you can use that as a reference app for doing that. With Micronaut, you can essentially take the same app and you can deploy it to Lambda, Cloud Run, Oracle function, serverless, or package it up and deploy it as a WAR file to a serverless container, or deploy it to or as a fat jar running Netty, or pick your deployment destination basically. And that's a compelling model. Because you don't have to rethink how you build applications, and you can basically choose your deployment destination, like you said, and you can kind of even do it halfway through the project where you're saying, okay, this service is not getting much traffic, so maybe it makes sense to shift this one through to serverless workload, and very little code change, pretty much no code change.
And this is huge. I would say this is huge because this is I would say simple programming model. You have the same API, and you can decide later where to put it. And I would say this is not emphasized a lot, but it's a huge selling point of the modern Java frameworks that they can actually do this.
Yeah, absolutely.
This is not obvious.
And we've spent with Micronaut significant time investing in that space. So we have support for Google Cloud Function, Azure Function, Cloud Run, Lambda, Oracle Function. all those different serverless environments. You can take an existing application. If you include the JAX-RS module that we have, you can put JAX-RS annotations on it, and you can push it to one of those serverless environments and run it behind. In the case of Lambda and Oracle function, you need an API gateway in front of it, but that's fine. Put an API gateway there. You can even generate the API gateway configuration from Micronauts. Micronaut has built-in support for building your Swagger definition at compile time from your endpoints. Mm-hmm. So you take that build time Swagger definition, you feed it into Oracle function or Lambda's API gateway generation tools, mm-hmm. and it'll generate all the routes for your Lambda and from the Swagger, and you're done.
How far are you with the CDI extension on Micronaut? Is this any progress, or are you still officially only supporting the GSR 330, or are you more towards the more complete CDI spec? So what's the progress? You said that you already supporting producers and disposes. Is this supported on paper or already supported by the framework?
It's already supported, but in a project we haven't released yet.
Okay. Okay.
In additional layer, basically I'm about 50% of the way through. So all of the scope annotations are supported. Normal scope is supported. Contexts are supported, like ApplicationScoped and defining your own context. Mm-hmm. Programmatic lookup is supported. Injecting of instance is supported. All the different annotations or disposal methods are supported. I think what I have left to do is implementing support for CDI events mm-hmm. API, mm-hmm. And build time extensions. Everything else is pretty much done. So I suspect we will have something more concrete to announce in Q3 timeframe, I imagine.
Okay. And do you have any plans to support more of the MicroProfile specs, or is just not on your horizon?
So the plan there is, the CDI Lite implementation based on Micronaut will be essentially be consumable by Helidon, right? So Helidon will use Micronaut for dependency injection and CDI support instead of Weld, as it's based on now on Helidon NP. Or at least it will provide an option to run on Lite. And Helidon is already MicroProfile compliant. So you would essentially, Helidon would essentially become the MicroProfile version of Micronaut.
Very good. So it means because Helidon right now still relies a little bit on reflection, and with your work on CDI Lite, they will be able to do more build time optimizations, right? So they're going to be
exactly. So every single, once they move to using Micronaut CDI Lites for all their modules, they'll all be AOT ready automatically without them having to do any additional work to optimize them for native image. And reflection will be eliminated. Startup time will be a lot faster for MP, and it will provide a essentially native ready MicroProfile runtime.
These are great news. And what will be the distinction? So the Micronaut will be more about Spring compatibility, and the Helidon more about MicroProfile compatibility, or what would be the distinction between two from the API perspective?
Well, I think this is kind of it's like a little bit like a conversation where people come to me and they say, Micronaut is a web framework. No, Micronaut is not a web framework, right? It's mm-hmm. It's a general purpose application framework that provides dependency injection, AOP, build time enhancement and analysis of your application build. So Helidon doesn't provide any of those things. It's really a microservice library, right? Mm-hmm. So the frameworks are hugely actually really complementary. So Helidon would essentially provide an audience for the MicroProfile community, and it'll be powered by Micronaut. And, on the Micronaut side, the Micronaut already has a very large existing user base that are happy with the, existing APIs, and we have to continue to maintain those. It may be the case that, that side gradually moves towards more wanting to engage with the standards, and at some point we make a decision. But ultimately, there are a lot of features in Micronaut that users enjoy. So, and really the real benefit here as well is that, Helidon will be able to use any Micronaut module, right? So whether you want to use Micronaut data or send messages with Micronaut Kafka, or you want to send messages with any of the messaging modules from Micronaut, whether it's JMS or whatever, you can inject those. Micronaut has like really broad support for much broader than Helidon's support for alternative clouds and so forth. So it potentially could be an avenue for getting Helidon running on serverless more, and so forth. So there's lots of different potential integrations, and actually, in terms of overlap, the frameworks only really overlap in one area, which is how you build the HTTP layer in Microsoft, right? So,
no. For me, so what I really appreciate in Helidon way, so I have just one dependency basically. This is the MicroProfile, and the other one, which I forgot, this was like this is a minor one, and I'm ready to go. And in Micronaut case, is more like specialist tool. I'm creating a highly optimized runtime, but I have to know what I'm doing. I would say it's really hard to start with Micronaut without the launch wizard, right? Because you will have to set up the annotation processor. So I tried that, so I managed to do this, but you have to know what you are doing. So you cannot just create Maven project with Micronaut from scratch, right? Would you be able to do this, to create Micronaut, let's say a JAX-RS bean validation project with Maven without the launcher from scratch? This would be a challenge, Graham.
I would be able to do it with Gradle pretty easily, because Gradle.
Gradle. Okay.
Gradle has much better support for. I wouldn't say much better. It's just much more syntactically concise.
Yeah. Okay.
With Maven to set up annotation processes is a bit more.
Okay. Yeah, but because we had the plugin, exactly. It was a little bit verbose for me. So, okay, this does not look clean. Yeah, okay.
But it is kind of solved quite a bit. We did a lot of work in the more recent version of Micronaut for Maven users to basically add a parent POM.
Okay.
So in fact, to get going with Micronaut today now for Maven users, you actually only need one line at the definition of the parent at the top of your POM, which is either Micronaut group ID, artifact ID, Micronaut parent, the Micronaut version you're using, and then you're pretty much ready to go. One dependency on Micronaut inject, and if you're using dependency injection, and one dependency on Micronaut validation if you're using bean validation, and you're ready to go.
Okay.
And it will set up all of the annotation processes for you automatically without having to do anything yourself. So yeah, we have worked on improving that scenario for Maven users. And actually, if you mentioned launch, it's actually a good reference as well as to see how things are done. Because you go to Micronaut launch and you select Maven as a build tool, and you click the preview button, you can select the pom.xml and see what a Micronaut project's POM should look like, essentially. So there, it's not so bad with the parent POM, in terms of setting up.
Yeah, I'm a little bit careful with all the launchers, because I don't know whether you ever saw the Whitefly Swarm wizard back then. It is now end of life, and I always used the Whitefly, and the Whitefly had one dependency, and I was happy, right? And the Whitefly Swarm they ask me, would you like to have JAX-RS with transactions, JAX-RS without transactions, JAX-RS with this transaction manager? And then I have to answer, 20 questions. And at the end of the day, I got something similar, which I had, for 10 years. And I said, what do you want it from me? And so what I also appreciate is like build simplicity, right? If the build, from my perspective, POM or Gradle, is part of the source code. And it also has to be clean and simple. And what I think the Helidon already doing this, you could prepare some kind of a profile. It's like no, this is my common dependencies, and this was my question regarding MicroProfile, because it's obviously there are a couple of dependencies which we always have, and then you only have to add this, and you are done, right? So if you add such a thing, a prepared, BOM or whatever, then everything is set up. And the cool story is, what I really appreciate is, you are not a unique snowflake, because every project is a little bit different. If you get a problem, you're probably the more different you are from the others, the harder is going to find, the answer to your question. But if everyone runs the same build, there is a more probability that you will find, the solution to your problem, right?
Indeed.
Okay.
Yeah.
But another question. Cloud events. This is like, are they any significant for Micronaut? Because this is a spec. The question is, is it a nice spec and very simple, to consume and to produce? Do you have to do something with the cloud events in order to integrate to the clouds, or is it not on your radar right now?
Cloud events are not on my radar right now. There's so much, going on. Things are always like changing and evolving. Mm-hmm. But I guess it's something I do need to look at. Thanks for pointing it out. I'll certainly take a look at it.
Yeah, no, it's just a very simple spec, JSON-based, so it's very easy to understand. But it is like, several clouds are probably using this for emitting events, and I thought you already had to consume the cloud events and translate them to HTTP or whatever. This was the question, whether you had already used that because of cloud integration or not yet.
Not yet.
So, one question. So you are the expert. I cannot pronounce this right. Micrometer or micrometer. How you pronounce micrometer?
I don't know. Some people say micrometer, others say micrometer.
Micrometer, exactly.
I think when I'm speaking to US people, most of them say micrometer. I don't know if it's. Who knows? Who knows? I think either is fine.
Yeah, there's a little bit drama in MicroProfile spec, at least from my point of view. So what MicroProfile metrics did, which I really liked, was there was a separation between technical and business metrics. So there were two scopes, like metrics. This was the vendor or application specific metrics, which I ignored usually at the beginning of my projects, and / application. This were these metrics which I created by myself. I could create my own metric registry, and add, the metrics, and then I only saw these metrics in the registry. So now what Quarkus did, they say, okay, future is micrometer, and the problem is now I have to fiddle with filters, and I'm absolutely not interested, to play with filters and whatever. So I would say this is very common use case, at least in my project always was, to separate, the KPI or application specific metrics, like my counters, how often Micronaut was downloaded and how often the download failed, like a very specific KPIs from garbage collection, RAM, and all the stuff which I don't care from the application perspective. And it seems like that in the micrometer world you have to build it by yourself, which I was amazed, because it's a mess, and at least it would be a mess in my enterprise projects, because no consultant would think from beginning about the separation. So I would assume it's a common best practice to separate, like if you have Prometheus, two registries, like, the technical registry and the business registry. So you have any thoughts on that, or?
Yeah, it seems, I mean, I think in most cases you would just separate them by a namespace, the way you're reporting metrics to in the Micrometer world. But, within the case of Micrometer, I just think, developing metrics stacks, the complexity with metrics is in developing metrics backends, and like reporting metrics to different backend registries. And Micrometer is one of those things. It's a project that came out of some experience from John Snyder, who basically worked with Netflix and looked at their requirements. And I think it's one of those things that you often see this battle play out where there's like an attempt to like standardize something versus an attempt to versus a open source project that becomes de facto standard, right? And that's essentially what's happened with Micronaut. Micronaut is like de facto standard, right? Because it's integrated with Spring, it's integrated with Micronaut, it's integrated with many other different projects. And what the Quarkus guy just realized was the amount of effort to build out all the different metrics backends that has already been done with Micronaut, because Micronaut supports everything, right? Every cloud, every it's just immense. And like we're trying to re-architect that into a standard. It was crazy. Probably what they maybe could have done is tried to have MicroProfile metrics backed onto Micronaut or somehow. But ultimately, Micronaut has become a bit like SLF4j or many other libraries. But like even Zipkin. Zipkin is pretty much de facto standard for distributed tracing.
Not Jaeger?
Jaeger is still, Jaeger attempted to rebuild tracing, distributed tracing based on, work already undertaken in Zipkin. Zipkin again came out of Netflix as well. They attempted to create certain standards like open tracing. And that whole thing was a fiasco as well, because open tracing was, this new standard for tracing. And Jaeger supports it. Zipkin didn't. And then, if you like a year or two later, open tracing is deprecated. And we have like open census, and then our open census is deprecated. Now we have open telemetry.
Exactly.
So attempting to standardize those problems like metrics and distributed tracing have failed repeatedly. And I think, in my opinion, MicroProfile metrics is just another example of that, right? You can, and now what the world we live in is you have Quarkus, Micronaut, and Spring using the same metrics backends, which
and Helidon as well. I think Helidon also moves to
right. Helidon just added Micronaut support because they had to, right? Because now because everybody expects their metrics to be in the same format now. Whether you're building with Helidon, whether you're building with Spring, or whether you're building with Micronaut, or whether you're building Quarkus, they expect the metrics to be coming into the backend in the same shape. And that shape is what Micronaut defines, pretty much, right?
That's interesting, because from developer point of view, I have complete different experience, because what mattered to me that the metrics emitted by something are Prometheus compatible and now open metrics compatible, but it should be somehow consumable by Prometheus. So for me, Prometheus was like de facto standard everywhere. And now even AWS and Azure recently provide out of the box support for Prometheus in CloudWatch, and recently Amazon even you can install manage Prometheus. This is very new service. It seems like the open metrics and Prometheus standards gets more and more accepted everywhere.
Yeah, I mean Prometheus is extremely popular.
Yeah,
I'm not sure if it's really reached de facto standard. It's certainly one of the most popular.
Yeah.
But Prometheus has a particular model, right, which is based on each microservice or application exposing a Prometheus endpoint and then having a centralized scraper that
exactly
scrapes all the data.
Exactly.
And then you have different metrics backends that don't support that model. Then they're more like a push-based model where metrics are centralized. So I mean, and Micronaut supports all of those backends. So really you're running reporting metrics to a specific cloud system, or you're reporting metrics to StatsD, or you're reporting metrics, whatever you're reporting metrics to.
I know. So Micrometer but I hear you, but I would say MicroProfile should not implement the metrics. It should just provide the annotations and the API, and they could absolutely use Micrometer behind the scenes. So this is absolutely.
Yeah, I think what could have been done is, you're right, but I wasn't involved in that decision, so I don't know. But what could have been done is they should have kept. So one of the problems with common mistakes with like standards, and this is actually why we're in this situation with now CDI and becoming CDI Lite, is because there's often like overreach in specifications, right? Where they try to do too much, or they try to define too much, and that's the hardest thing I think to get right, in any standard, right? It's often better to like keep it narrow, like JSR 330 is an example of that, where very focused, small standard, easy to implement, etc. Well, CDI is like huge. I mean, it's like enormous, right? Beast of a specification with lots of different moving parts and lots of assumptions and requirements and whatever else.
What happened to CDI? Just a funny thing. As it came out, many projects thought, enterprise project thought they have to use everything, and they used all possible features from CDI like crazy at the beginning without no reason, everything were interceptors and decorators and stereotypes. And I say, why are you doing this? I mean, we have a simple CRUD application. We don't have, to be able to replace every class and makes everything, composable at runtime.
Yeah, exactly.
Because in enterprise project, everyone will try to implement everything,
Yeah, I mean, the runtime extension model in CDI is just like incredible, like nuts. It's like, it's so dynamic. And so, and I think like in general, like if I had a recommendation for like MicroProfile is like just keep the standards like narrow and these are the annotations, how the metrics are reported, like is relevant to me. And I think that would have been, a better scenario. And the same thing for other aspects, I have concerns by other standards in MicroProfile, for example, MicroProfile messaging, where they're prescriptive about a certain API I think it would have been better once again to just define, this is the outgoing annotation, this is the incoming, and leave like how the actual consumption of the message, like how, well, this is like what a message of interface looks like, and that's it. And the actual consumption of how the message like operates.
You are absolutely right, because from the matrix, usually what I did, I just injected the registry, which was the MicroProfile registry. But what I just did, I created a counter on the fly, increased the counter, or I exposed a method as a gauge. So this was what I was looking for, and whether it would be implemented with micrometer or not, I don't care at all. I just need something to be increase and decrease, and now it seems like the micrometer is the preferred thing, and I will have to implement the distinction by myself, which I don't like at all. I mean, it is not a lot to do, but you have to be consistent in every project to do the same. And this is lots of repeating overhead in enterprise projects. And this is what I don't like at all, not appreciate at all. But this is just my thought. And I know you are micrometer, and there is a tutorial micrometer in Micronaut. So I was just curious about your opinion about that.
Yeah, no, I get what you're saying. I mean, that's also why, I understand the MicroProfile's kind of philosophy is like, to try and move fast, but it's like a little bit like replicate the spring. But like that's the problem with specifications, right? If you move too fast, then
you are not backwards compatible.
You have to backpedal again. Yeah. And this is why in MicroProfile, people have to also realize MicroProfile is not really like a set of specifications, but more collaborative framework, right, between different companies. It's so, and that's different to Jakarta EE or anything else, which is fine. But that's what it is. It's not like it doesn't appear to be at least guaranteeing compatibility in the same sense.
Perfect. So what I would like to do is re-invite you back until CDI runs perfectly on, Micrometer, so officially, so I can try it out and give you feedback. So we could have a chat about that
on Micronaut, yeah, for sure. Maybe we can even get you some early access or something.
This would be nice. I would like to play with it, and then we have a chat, and we can, have a chat about that.
Sure, sounds awesome.
Thank you. What's your Twitter handle?
Graham Roche, all one. My name and surname.
Perfect. I really enjoyed the conversation. I learned a lot again, and see you next time.
Great. Thanks for taking the time to speak to me.